With a physical chemistry class, we need wavy motion of electrons, right? And we expect that it will be counterintuitive, and we do need some math that finally will come into the level of differential equations. So even in the middle of the class, we will vote for the form of whether to do exam or project reports. But even if majority will be for the exam, today's material will be not part of it. So if you are busy, you need to concentrate on something else and do your other homework, just lean back and relax. So I'm going to provide some concepts. They are less mathematical, they're more philosophical, they're more physical, they're less chemical. And by just getting general idea on these concepts, we hopefully will feel much better to describe wave motion of electrons. And it is not part of the course, even if we would take this as not as physical chemistry, but as quantum mechanics and physics, it still will be different course. So what we are going to chat about today, it is physics, classical mechanics, 400 levels squeezed in like half an hour. Not the math and the relations, but the concepts. And we need this seemingly boring and strange stuff. Oh, you came in person. Very happy to see. I'm not yet quite adequate. I recognize it's someone I saw before. Okay, so the way the nature of electron, quantum features of electrons are counterintuitive, but we will try to draw a path how to make some connections to our intuition. And this counterintuitivity is the major challenge. The mathematical things can be done by computers, by hiring professional mathematicians, but this counterintuitive things is what was bothering humankind a lot. So, if does anyone was connected to any sort of military training or activity? Does anyone is hunting? Yeah. So suppose you have like your rifle or cannon, and you do not need to hunt any specific prey. You just need to make a world record and throw your projectile as far as possible. So which angle should you put it? Should it be horizontal? Should it be vertical, up, or some specific angle?
45.
Yeah, how do you know it?
That's in the middle.
Huh?
It's in the middle.
But can you prove it without, like experimentally, you just shoot at different angles? If you need to prove it mathematically, is it possible? What are the major steps to this proof?
You need to use the you need to use Newton's Newton's laws of projectile motion.
Yep. So it will be like you decompose it on horizontal and vertical, and in vertical this component will be compensated by free fall acceleration, and then it will come. But as a result of such calculation, you get a trajectory. You can predict on which path it will go. It will be something like parabola, quadratic with whiskers down, right? So if we speak about anything we can carry and touch in the macroscopical life, we have our intuition, and even if we do not practice math and equations of motion, we have a concept of trajectory, right? That it goes along a certain path. This is intuitive concept. The wavy motion will be much less intuitive, and some words that I'm going to mumble and maybe show some equations will be foundation to connect concept of trajectory to things that you have like. Okay, what else? So the you mentioned Newton's equation of motion, right? which is cool and practical in many simple cases, but it is not as general, because if there is a complicated mechanical system with like several pendulum connected to each other, it will be big headache to practice Newton's equation of motion. There is a replacement of Newton's equation of motion, which is more general and work for basically any system. And this replacement of Newton's equation of motion is so-called Lagrangian equation of motion, which is based on least action principle. Right? So we just need to go over these concepts, and they will serve as an output of our today's unit, and they will serve as an input for our meeting on Wednesday. So what do you think about least action? You were like noting that it's something that is not new for you. So what is it? I can give an example. If I do not want to act and I want to lay on sofa, it's my least action principle. Do you have any better example? Have you heard this combination of words before? Never? No one? It's just good combination of words that appeals to human heart and brain. Okay. So then I'll go over slides and so it is what we were doing last time before the weekend. We looked onto the standing wave, which is decomposed as spatial and time-dependent part. And then this is from some other year, but you were doing it recently. And by doing this mathematical experiment, by taking derivatives, we agreed that by taking second derivative of the thing that performs wave motion, second derivative of position, second derivative of time, they will be equal, and this differential equation generates waves. And for an electron, I'm going to very slowly introduce it, but maybe some of you are already curious. For electron, instead of second derivative, there will be first one, and it will be also multiplied by imaginary unit. And it justifies why we already spent some, we talked a little about imaginary unit. But to come to this equation, it took like a lot of years for humankind, and it will take maybe a couple of meetings for us so that we go slowly but surely. And the wavy equation for electron will be part of exam if you select exam, or will be part of the project if you, because everything will be based on this equation. So we discussed this non-flight TV and watched some interference picture and did this. I will not run this again, you saw it, right? And then I think there was a question. What is moving here and where we go from here? So this image has this double line as a like 0, and the green going positive or negative means intersecting the stuff. So it's like a cosine function projected on a circle. And this image, this concept of a wave going on a circle integer number of times is a wrong theory. We cannot apply it. The name of the theory is Bohr theory, and it was the first quantum theory that gave some basic understanding of the things that were not possible to describe before. So it just brings concept of electrons as waves to practical dimension, and it was predicting the linear spectrum of hydrogen atom. So the main idea, and I want to shorten it as much as possible, we will have dedicated lecture for this theory about number 40. by the end of the semester. But the main idea is that if there is a integer number of nodes around the circle, this is a true state of electron that can exist, that has right to exist in nature and can be observed. If it is the fractional number of nodes, it will behave ugly and it will be not observed in nature. It's like short-living transitional states that are not observed. So this theory can be criticized, but if it has some grain of good sense, what is going across? How do we rationalize? How do we quantify the amount of these oscillations along the circle? And basically, this stuff referring to classical mechanics that we'll cover today will just bring us a little closer to understanding of this. So the circular motion deals with electron in hydrogen atom, right? And these nodes, like if there are two maxima, two minima, it relates to like P, D, F orbitals in very oversimplified way. And you should understand it as electron is going on this circular orbits, and in some places it has higher probability to be found, in others less. But it should be integer number of this maximum and minima so that it performs, it makes a standing wave. Now, this all looks as a crazy idea for a person of 19th century, because electron should be a position as anything. And electron is moving. So when it's moving on circular orbits, like a planet, how do you quantify that? What is constant or what is changing when it goes along the trajectory? Does this question make sense?
Energy.
No, not quite. Energy is constant. Yes, this is correct. But what is changing along this trajectory, and what else in addition to energy is constant? So does the question make sense? Not or you need more words about the question itself? Feel free to just tell yes or no, it's not clear. Yes. Everyone is okay? So if we are thinking as people like 200 years ago, planetary motion, electron has position, which is distance from center and like place on the circle, and it has velocity or momentum, right? So when planets were moving, there were like Kepler's laws that they slightly deviate from circles, but they still have the certain thing that is constant for along the planetary motion, which is
speed.
Huh?
Velocity, speed.
If velocity is a vector, it changes its orientation, so it cannot be constant. It's only for linear motion. The velocity and momentum is constant. But your thinking is very in the right direction. So for linear motion, the amount, the way to quantify motion is momentum, right? But for curvilinear motion, a circular motion, it changes angle, but it angular momentum. So it's like analog of linear motion, but a little tweaked to describe curvilinear. And this is a product of distance from center by momentum. And if you want to be meticulous and rigorous, it's a vector product, right? Like cross product, which goes out of plane. So for like if I would take a rope again today and put like piece of stone and start swinging it with constant velocity, the angle will change of velocity, but this thing, distance from center, which is the length of a rope, times momentum will be constant. So the angular momentum is the way to characterize circular or like elliptical motion. And if a planet is not perturbed, if it moves on trajectory, the angular motion is considered constant. So energy is conserved and angular momentum is conserved. So the Bohr theory, which is not subject of today's discussion, basically told that only those orbitals of planetary orbitals of electrons are allowed when absolute value of angular momentum takes integer number of some small number of Planck constant. So it allowed to have discrete values of angular momentum, which is very hard to justify based on our everyday experience and all science before advent of quantum theory. So it means that I cannot rotate the stone above my head with any angular velocity, with any speed I like. It's allowed slow, substantially quicker, and there are no ways in between. And visually, it refers to integer amount of these fringes. So I understand where I want to arrive, but every year I have difficulty to pronounce it because it's an attempt to connect inconnectable. The angular momentum with r times p takes discrete values of Planck constant. And right now we don't need its numerical value, we'll go to things later. And the dimension of this angular momentum and Planck constant are the same. So this will be dimensional or dimensionless thing, or more specifically, dimension will be radiance angle. And this stuff needs to be discrete times full angle. So this angle relates to this figure, and it looks like this angle is something that we need to substitute into this cosine function, right? But by now, based on the words we discussed, I have no idea what is this angle and why the angle and why cosine function should be attributed to any circular motion. So it's not a problem of math, it's a problem of lack of language. So we need to develop concept that would allow us to relate this circular motion with some angle, something is developing and increasing along the trajectory that we can place into trigonometric function and justify this nodes and lobes. Make sense? So, okay, what is oscillating in Bohr's scale? So to speak about it, we need to introduce a couple of concepts. So we just refresh our vocabulary from high school physics or maybe college physics. So any of these words new for you, or let's go through the first one. You can just vote us in circus. So trajectory, will you please vote if you're fine with this concept? Or down if everyone is fine with trajectory? Okay. Kinetic energy. Your name is Josh? Josh. Kinetic energy, good or bad?
I think kinetic energy is easy.
Okay, yeah. Please, I'm just gauging and measuring if I need to stop and talk more or it is fine. So potential energy. Everyone is fine? Okay. Hamiltonian operator. do not hesitate to show. Okay. If we add together kinetic energy and potential energy, it will become a dynamic operator. Make sense? Good. Now, Lagrangian operator. Okay, if we subtract kinetic and potential, it will be Lagrangian. Okay? So quite simple. Now, equation of motion. You can yes, no, or something in between. So it's like Newton equation of motion that generates trajectory, right? Okay, and now action. I would expect everyone would show that it is needed. Or you show yes? Action is fine. Can you tell us?
So action is it's a numerical value that okay, say for example, I'm trying to go from here to there. I need to look for the least distance I can travel to get to that point. So most times action is a value in physics where systems try to look for the least possible way to arrive at something.
Excellent, excellent. Yeah, thank you. Does it make sense for everyone? So it is a way to quantify this principle that arrive by shortest path, maybe even shortest time with minimal resources. And basically, I just don't want to dive into equations so that we do not lose connection potential. The concept of trajectory, equation of motion, and action are all connected together. So when we solve equation of motion, we get trajectory. And trajectory of all real objects are happening in such a way so that the action along this trajectory takes minimal value. So if you, and this is an idea behind physics, mechanics, classical mechanics, and like one semester of 400 course. So with action is a principle how one can find motion of any mechanical system. This concept of action is connected to all things above. And this connection will be not too challenging. Just from listening to your answers, I'm confident. This is so ugly. This is better. Let me see if. Yeah, I think we can go with this type of things. I don't need to scratch it. If something is not clear, I will write it over with ugliest. So, kinetic energy is velocity squared times mass divided by 2, right? Everyone is clear. And velocity is just derivative of position over time. Right? Now, next thing. This is only example, it's not genuine, but if we have like favorite toy in physics, like mass on a spring or swinging mass that oscillates, the potential energy is elongation of the spring squared. Basically, it's some function of position. Okay. Now, Hamiltonian or total energy is kinetic plus potential. Lagrangian is kinetic minus potential. Then Newton's equation of motion is force equals mass times acceleration, right? And Lagrangian equation of motion is formulated this way. If one plugs in this stuff into this equation and practice it, just take derivative of Lagrangian over position, and then derivative over time over this derivative of Lagrangian over velocity, when you arrive to the same equation, force equals mass times acceleration. If you would be in physics department, you would spend 2 months on practicing it for any system. Now, if we know the Lagrangian, and if we already know the trajectory, so one can take the value of this Lagrangian at each point of time and at each point of space along the trajectory, right? And then integrate it over time from initial to start to final point. So this integral is named as action, so it is strict definition. And there are like philosophical and mathematical reasons to accept that material objects along trajectories that they show in nature, they always follow this least action principle. So one of the ways to find a trajectory of an object, like always let an object to move any arbitrary trajectory, calculate action for it, then draw another arbitrary trajectory, calculate action along it, and then compare which one provides smaller action will later be observed in experiment. And it can be done completely by random, just guesses through random numbers of a trajectory. The one with smallest action will be true. Okay, now you got full credit for physics 400 classical mechanics. What is the dimension of this L function of Lagrangian? Okay, what's the dimension of Hamiltonian? Okay, what is the dimension? What's the dimension of length?
2D.
Huh?
2.
No, not like three-dimensional, zero-dimensional quantum mechanics. Huh? Units. Units of length are like meters, right? What are units of time? Seconds. What are units of velocity?
Meters per second.
Just meter per
Meters per
second.
second, yeah.
Or between us, we can just tell lengths per time. Okay. What's the units of kinetic energy? Oh, what's the units of mass? Like kilograms or pounds. And what's the units of kinetic energy?
Joules, right?
Joules, yes, units of energy. Or we can decompose it onto mass times length squared over time squared, right? So mass times length squared over time squared will be units of energy. And later on, you can name it on joules. What is the units of potential energy? I'm bored to decompose it, but since they are additive, it should be the same units. Okay. What are the units of Lagrangian? Since it has the same components, it should be the same units as energy. And what are the units of action? Multiply by time, right? If here we had mass, length squared, time squared, in action we just cross out one time in the denominator, right? Okay. What are the dimensions of angular momentum? And I'm not going to torture myself and yourself. These questions will funnel and arrive to the conclusion. It's not a silly drill.
Eurasians, curly.
So position is like length. Momentum is length over time, right? So let's work on it. So length, and in addition to length over time is mass, right? So length, mass, length, time. So length squared, mass, and line somewhere. There shouldn't be. Let me correct myself. Better? No, I'm not lying. And here we can identify this stuff. If you look at the previous slide. So mass, length squared, time squared, which is the units of energy, right? Now we see here mass, length, and time. So those are units of energy. And then just to have this denominator, we have units of time. So, and here is a little surprise. I'm not going to jump and say, what a surprise we might have discovered because people knew it. But there is a little observation. The units of angular momentum are energy times time. And units of action are also energy times time. We do not know why yet, but we objectively observe this correlation. And if we accept this observation, we can go wild and make an assumption that is not proved and justified logically, but it will give us a way out of this problem. So we were asking ourselves, what is oscillating along a trajectory of Bohr electron in Bohr atom? Why the angular momentum takes discrete values? So what is increasing along this trajectory? What is placed as an argument to this trigonometric cosine function? Right? So now we do see that the action and angular momentum have the same dimension. So maybe we can get benefit from this observation. And the way how people want to think about it is that as electron is moving along trajectory, longer and longer trajectory, it accumulates action, right? And this action, because of the relation to angular momentum, is basically what is used after a conversion factor as an angle, as an argument of trigonometric function for this electronic wave. I'm impressed myself. So there is a connection between action and angular momentum, and we hypothesize that as electron is moving along trajectory, that accumulates this action, and it is placed as an argument to for trigonometric function of electronic wave. Then it also, I wouldn't say it is completely convenient, convinced everyone, but it makes a little bit more sense to accept this discrete values of angular momentum. So we expect that action should be minimalistic. So if it will be like very small number is okay, but here it is a little expansion. Instead of minimalistic, it should take discrete values. So such trajectories are allowed where action along these trajectories take discrete values. So let's try to summarize just what how you interpret last statements. maybe I invite everyone, if you're taking notes, just write one sentence. How do you summarize what we just discussed? And then we will just read out. Because, yes, just try to type, all right? I'm not sure that I expressed it in the best way, but probably the idea was communicated and your words could be better than mine.
Yeah, I don't know, but I quite fully understood what you said.
So don't worry, it's not reading, it's more feedback from you.
I heard you say at the end that action can be measured in discrete values. That's like all my brain took in there.
Any connection to circular motion?
I can't remember really.
Okay.
Yeah.
Thank you.
Yeah.
Just, will you just summarize what you?
I honestly don't know.
Okay, but try to while we are speaking, try to write down by words.
All right.
How you summarize.
Action and angular momentum have the same units, and then from what I understand, so action follows discrete values, and then while angular momentum is minimized, is it travel? Yeah.
Okay, yeah, thank you. Would you like to?
So everything, okay, so basically, I kind of just wrote down what we were saying, where you like talked about how as an electron is moving along the trajectory, it accumulates action with the constant energy of the time. And then I also wanted to write what he said about based on the equation, we determined that both action and angular momentum have the same like we end up with like the same dimension, basically energy of times multiplied by time. And yeah, that's all I would say.
Okay, yeah, thank you very much. Thank you very much. So you're still taking? Or would you like to tell your reason?
Okay. I've actually traveled to New Travel too. And I'm not really sure what exactly it is that is changing. So, but from the equations, we observe that action and angular momentum have the same dimension. So probably somewhat related. So somehow, as the electron travels on the trajectory, action is accumulated at the same time it needs to be minimized, and therefore it's somehow related to the electronic wave function because of the cosine function.
Okay, yeah, thank you very much. Okay, so it's time to speak.
I'm not sure this is right, but so as you said, as an electron moves about its trajectory, it gains action, and since we observed that action and angular momentum have the same dimensions, it could be said that like it contributes to like the phase angle of the wave. So I think that's kind of what it's measuring, I guess. I'm not quite sure.
No, it's great. It's great. Yeah, thank you much for all your contributions. And I think if we listen to recordings, I probably will learn from you how to formulate it better next year. But if holographically connecting all you've told it's a best definition. So It looks like last slide, yes. So we are earlier than expected. The summary is that energy times is action, and the action can be based on the similarity is our suspect to be placed as a phase angle for the oscillating electronic wave. So it was our main counterintuitive philosophical question, like if you draw waves, what are the arguments? What is changing along space and time, which defines what is the minimum and maximum of the wave? And now we have a good hypothesis that action corresponding to trajectory arriving to a certain point will define the phase of the wave function at this point. So it is some positive hypothetical knowledge that you can use as a foundation to build our understanding of electron as a wave. So I'm very happy with outcome of our meeting. It was maybe just a couple of sentences in your notebooks, but it is an important thing that if we would skip and go immediately to the material that follows, there will be a lot of confusion and misunderstanding. Now, do not think it was a waste of time. It's we slowly but surely set up foundations. I think we are done. The remaining 4 minutes are yours. Meeting is done. Everyone is welcome to depart. We didn't accumulate enough knowledge to try any homework, so just accumulate strengths and looking forward to seeing you one day. I'm going to disconnect from Zoom, but I will stay here to answer questions if any. But it's okay to meeting. Alison, are there any questions?
Nope, it's all clear to me. Thank you.
Okay, yeah, thank you. So with your permission, I'm going to disconnect.